right? So triangle fun, right? You're given a bunch of information, two sides and an angle, and you're wondering, is this SAS, right? Where the sides are on either side of the angle, or is it a pair scenario? And it is a pair, right? Because you've got the angle and the side opposite. So it's SSA. So we actually need to check if there are multiple solutions. The string is shorter than the rod based on the numbers. If it had been bigger than the rod, no worries, right? You'll actually, if you review and you go back, if ever you have an SSA, I make sure that the string is longer than the rod, then you never have to worry about it. It's one solution, right? But here the string is shorter, find the height. The string is bigger than the height, and so therefore you've got two triangles or two solutions. So that would be the justification part of what happens next. I took the liberty to already solve for the first one. Okay, so it swings out, the string swings out, so this is what you get. Why did I put U here? Well, if you can recall, the other side given is U, right? So if U, side U is here, angle U is there, which means angle N has to be up here. To distinguish between them, I go 1 and 1. To be honest, if you just separate your work, I'm okay with you not doing that. I just like to have the distinction there. And most of you will get, right? You know how to solve this. This is by default what you should be getting. So angle U is this, which allows you to solve for angle N, and which in turn allows me to solve for side N, and I use cosine law. You don't have to use cosine law. You can use whatever works for you, but you end up with 10.64. Are we good there? Yeah, a few that got that. I see some nods. Okay, phew, because I just made this up. But yeah, that's what you get for, and so that's your long side. Then you're like, okay, this string now swings in, right, to make this triangle. So this is the one that I like. Yeah, I want to see that you're considering two options, right? Or else you're missing the point. And so to find U2, all you need to do is you go 180 minus U1. Okay, you take this angle, just subtract it, because if you don't, your setup is going to look exactly like before. You're going to end up with an acute angle, which is not the case. It's going to give you this acute angle here, but you want this. So you just go 180 minus whatever you got it here. So U2 is, oops, 180 minus, I wanted to do this part separately. So you got 116.27, which means that N2 is 180 minus 51 minus 116.27. Okay, so it's 12.73 up there. Both of these are important to me. And then now you can solve for side N2. I will just basically base it off of this here. N2 squared is 10.5 squared plus 9.1 squared minus, don't rush here, you show me all your work. This would be cosine of 12.73. And so N2 is the root of all of that. So I'm going to go copy my previous cosine law entry, this one. But I'm going to replace this with 12.73 here. Hit enter. So you get 6.65 and something. So then I'll take the root of what I just got. So my answer is 2.58. And we are in centimeters, right? So I would like you to, that N can be 2.58 centimeters or 10.64 centimeters. And it also goes without saying that angle N could be 65.27 or 12.73, right? Or that angle U could be 62.73 or 116.27. So for every missing piece, there's two possible answers. It's a lot of fun, right? There we go. It took me, what, 5 minutes? Well, I already had it started, so let's say 7 minutes. But yeah, there will be something like this on the test, so make sure you know how to do it. That's part of one of the outcomes for this unit, okay? All right, keep going. Let's see, I'm curious if you were able to be honest, is the sketching of it, that is probably the biggest hurdle. After that, you're all pretty good at solving. So let's see here. Elijah would like to visit his friend Dustin. Elijah leaves his home and drives 13 kilometers at a certain direction. So you've got both, okay? Distance and direction. South 15 west. So again, you're gonna have on your study sheet, you're gonna have hopefully, because when you're writing an assessment, you're nervous, you make silly mistakes, right? So this saves you from doing that. So that we're going, so just picturing this, we're starting south and then we're going 15 west. So be going this way, stops, refueling, and then 10 kilometers west. See, so west, 10 south. So you're gonna go like this. Okay, so you're going kind of like in the same general direction. So let's do this again. I'm gonna start it. South 15 west. So this is my south. We go 15. It's not a whole lot, but that's my direction here. So make sure you put the 15 in here. Okay, between that dashed south line and your actual path, and that's 13 kilometers, sorry. And then you're again at this point given compass directions. So I'm going to make sure my north-south goes through it and my east-west. So this is going to be somewhat tricky. This is my west line here. So it says west 10 south. So it's not a big angle if you think about it. It's just like that, right? So we're going to go like this. The 10 is just in here. Okay, should I zoom into that? Let's try that. So that's what's happening. So this is your start. This is where you gas up, right? Refuel. And then you make it to Dustin's home, right? This is Dustin. So that's what's happening there. Look at the angles. Look at what I've done there. Okay. Now, we obviously have our triangle here formed. I'm just going to make a light line. I'm going to make a clean version of this yet. Oh, and this is 10 kilometers, correct? 10 kilometers. So we have this side, we've got this side. I'm going to say something here that is probably true 99.9% of the time. When you make your clean triangle, you're only going to have one angle inside that clean triangle, okay? So if you end up with like two, you're like, wait a minute, did I make an assumption that isn't true, right? Did I bring something over that isn't true, right? So that's what I want you to think of. So let's make our clean one here. I don't know. This is somewhat like it. Okay. And then here. So we can definitely say this is 10 kilometers and this is 13 kilometers for sure. Oh, the 15, let's just bring it in here. No, don't do that yet, okay? This 15 touches what? It touches I'm going to use highlighters here. It touches the south line. So therefore you can bring it over and it has to touch this vertical south. This is the north-south line, same as this. This is the north-south line here vertically. So the 15 comes in here. I can bring the 15 in there. Yikes. but I'm going to try my best here. So that's 15 in there. How can I get an angle here? What do I have between this one and this one? That is definitely a full-on 90, correct? Okay. So now you have to be careful. This is 15 and a 90 and another 10. That's what you have in this corner here. It's an obtuse angle. Okay. So you've got 15 plus 90 plus 10. That's 115, correct? There we go. Did you get that? Just pay attention and try, right? You try. After today, you're going to go grab a bunch of compass directions. You're just going to focus on sketching first and foremost. So we have a side angle side scenario. We've got the 115, which would be worth a lot in this case. I'm going to erase some of the stuff I did here. So what is it asking? Calculate the distance between the homes of the two friends. So it's asking for this. So it's cosine law. So x squared is 10 squared plus 13 squared minus 2 times 10 times 13 times cosine of 115. Oops. Stay inside the camera. There we go. X is square root of all of this. And I'm just going to give you the answer, 37.8 something. So that would be 19.46 kilometers. So this one is just one step to solve, right? So your diagram, so in terms of difficulty, it wouldn't be the most difficult. But maybe the diagram was for you. But I would also say your angles, make them realistic if possible. Okay, don't make a 10 look like a 40, right? It's 10, it's not that big. So try that, that's also going to help you out. Okay, next. The search and rescue helicopter completed a training exercise. The crew is flying 45 kilometers in this direction. Okay, turned, flew this, and arrived at destination. I just have direction, notice that. The destination is 75 kilometers from the heliport. Okay, determine the total distance the crew traveled. All right, so I again have this here going on for me. North, south, west, east. And I'm going north 25 west, so I'm going to go this way at first. And then turning, and I'm going to go southwest. So this is kind of like the path that I'm following. So I'm going to start here. North 25 west, so you're going this way, and this is your 25. Yeah, maybe use a ruler. Okay. This is your north, this is 25, and you're going 45 kilometers in that direction. Then you're going to turn. So at this point, you do another compass rose. I think they're very important because when you transfer, it's easier to have those there. This is south 51 west, so this is a 45, I would call this. So 51 is just a bit more, right? A bit more like that. So I would go in that direction, and make sure you put the 51 in here between this dashed line and your actual direction. And don't line up perfectly, like don't make it stop here so that you think it's perfect here. Either short or hyperextend, right? But don't do the other. So I will actually do this here, a light line there. And so what do we have? We know that this is my start. This is where I turn. This is your final destination. to their destination, at their destination. Arrived at the destination, never mind. The destination is 75 kilometers from the heliport. I guess it didn't tell you where the heliport is exactly. So I should be careful with that. But this is where the 75 is supposed to go. Otherwise, it would have given you a distance here, right? Flying this many kilometers in this direction, but they didn't. So this is what's happening here. What can you do, right? Well, we'll go with your starting point. This vertical, that's where that angle is touching, will obviously go with that vertical, right? So the 25 goes in here. I get to bring that in. And they're right next to each other, so I'm just going to add them up, and then I'm good to go. So, interest of time, I'll just do this. There you go. You can call this S, turn, D for destination. Don't put the 25 in here, right? It's just 51 and 25, which is 76. 76 degrees there. That comes with you. The 45 goes here. The 75 goes there. What is it asking? Total distance traveled. So total distance from start to here. So I guess if we're traveling, we're just wanting this here, these two. We want to add up these two sides, which we need to define this first. So I'm going to call this x. Okay. So we go sine of 76, because it's a pair, over 75. And that would be sine of d. That's all you can do is solve for d first and foremost, right? You can't jump to x right away because you don't know this angle. So go ahead and find d. I will just tell you that if you do this, time is flying. You get 0.582 and something, which angle D in turn is inverse of that. Angle D is 3560, which allows you to find angle S. Angle S would be 180 minus 76 minus 3560, and that is 68.4. All important pieces of information. Now that you have this angle, you can, I'm going to use the same pair that I had from the beginning, but I'm going to use angle S, so 68.4, to solve for side X. Once you do that, I'm just going to skip to the answer here, 7187 kilometers. So total traveled would be 7187 plus 45. That'd be 116.87 kilometers. And obviously, if you made a mistake upstream, I would still, as long as you still, like, if you still do quite a bit of work, you get most of the marks. If your mistake causes you to do this in like one shot, then you lose more than just 1 mark. Okay. All right. I'm going to ask you to just hold on to this